Geometric sequences. Note, given three consecutive terms of a geometric sequence, so term 1, term 2, term 3, for example, note that term 2 divided by term 1 is equal to term 3 divided by term 2, which is equal to or the common ratio. So this is for any three consecutive terms. It doesn't have to be the first, second, and third. Like it could be, for example, the 7th, 8th, and 9th, or the 3rd, 4th, and 5th, and so on. It just has to be three consecutive terms. This is very similar to the rule in arithmetic sequences that term 2 minus term 1 is equal to term 3 minus term 2 is equal to or. So very, very similar. Also, term 6 divided by term 5 is equal to term 12 divided by term 11 is equal to term 20 divided by term 19 is equal to term 100 divided by term 99, and so on. So the rule is term 2 divided by term 1 is equal to term 3 divided by term 2, which is equal to or the common ratio. Example 3. 3, x plus 6, ... are the first three terms of a geometric sequence of positive terms. Find part 1, the value of x, and part 2, the 10th term of the sequence. So again, our rule for geometric sequences is term 2 divided by term 1 is equal to term 3 divided by term 2. So I would not advise learning this off as a formula as such. Try and understand it as a rule and understand what it means and learn it off in that way. So term 1 is equal to 3. That was given to us in the question. Term 2 is equal to x. That was given to us in the question. And term 3 is equal to x plus 6. Again, that was given to us in the question. So we're going to use this rule and we're going to sub into it. So term 2, I've highlighted in blue. So we replace that with x. So that's our numerator on the left-hand side. Term 1, we know is 3. I've highlighted that in yellow. So that's our denominator on the left-hand side. Term 3, I've highlighted in green. So that's x plus 6. That's our numerator on the right-hand side. And term 2, again, is equal to x. That's our denominator on the right-hand side. So we're going to cross multiply and solve. Because remember, we're trying to find the value of x. And then once we know the value of x, that will help us find the 10th term of the sequence. So we're going to have x multiplied by x. And then 3 multiplied by x plus 6. So x times x is x squared. 3 times x is 3x. 3 times 6 is 18. So bringing everything over to the left-hand side, we have x squared minus 3x minus 18 is equal to 0. So remember, we're trying to find the value of x. We're trying to solve for x. So at this point, we can use minus b, which will always work, or we can try factorizing. So factorizing, we get the factors of 18. And this is a minus at the back here, so we know our signs are different. So one's a plus and one's a minus. We're going to go with 3 and 6 because 3x minus 6x is minus 3x. Factorizing the first two terms, we get x times x plus 3. Factorizing the second two terms, we get minus 6 times x plus 3. And then we put our eggs together. So we have x plus 3 times x minus 6. So x is equal to minus 3. And x is equal to positive 6. So this is just from the previous slide. So x is equal to minus 3 and x is equal to 6. So going back to our question, it tells us that our terms are the first three terms of a geometric sequence of positive terms. So again, from our question, we have term 1 is 3, term 2 is x, term 3 is x plus 6. So if we were to use minus 3, we would have 3, comma minus 3, comma minus 3 plus 6. So that's if x is equal to minus 3, which would give us 3, comma minus 3, comma 3. Because minus 3 plus 6 is positive 3. And if we were to use 6 instead, we would have 3, comma 6 plus 6. So that's if x is equal to 6, which would give us 3, 6, 12, because 6 plus 6 makes 12. So again, our question tells us that the sequence has positive terms. So these must be the first 3 terms of our sequence. So therefore, x must be equal to 6 and not equal to minus 3. So if the terms are positive, then our sequence must be 3, 6, 12, ... and x must be equal to 6 and not equal to minus 3. So our sequence is 3, 6, 12, ... So that's the answer. That's from part 1. For part 2, we have our Tn formula from the formula book. So Tn is equal to a or to the power of n minus 1. A is 3, and or, our common ratio, is 2, because to get to each term we multiply by 2. So subbing into our formula, we replace a with 3 in a set of brackets. We replace or with 2 in a set of brackets. And to get term 10, which is what we're looking for in part 2, we replace the n with 10. And into the calculator, we get 1,536. So the 10th term of the sequence is 1,536. Or we can again use our Tn formula. So Tn is equal to a or to the power of n minus 1. So T10 is equal to a or to the power of 10 minus 1. So T10 is equal to a or to the power of 9. And replacing a with 3 in a set of brackets and or with 2 in a set of brackets to the power of 9, again gives us 1,536. So alternatively, because we're only looking for the 10th term, so it's not that long, we could start with 3, 6, 12 and keep multiplying by 2 until we have 10 terms. And you'll get to 1,536 and you'll get the exact same marks for doing it that way.